everyone. Today we're going to discuss molecular compounds or covalent compounds. Now, remember, in a covalent bond, nonmetal atoms share electrons versus in an ionic bond where a metal gives one or more electrons to a nonmetal. So today we're going to discuss the covalent bond, but also how to name these covalent compounds. So molecular compounds form when atoms of two or more nonmetals share electrons and form a covalent bond. So the valence electrons are shared in order to achieve stability. So remember that every atom wants to be stable like a noble gas. So that might mean that they're going to share electrons in order to have 8 valence electrons. So for instance, let's say we have 2 fluorine atoms, and both of these fluorines, of course, are in group 7A. So they each have 7 valence electrons. Now, what these two atoms can do is share their unpaired electrons and form a covalent bond. So these are the Lewis symbols for both. And when they share their electrons, remember those shared electrons belong to both atoms equally. At least in this case. We'll talk about some situations where they're not shared equally, but assume that they're shared equally for now. So that means that the fluorine on the left has 8 electrons, or 8 valence electrons, and the fluorine on the right has 8 valence electrons. Okay. So how do we name these molecular compounds? So when we name a molecular compound, the first nonmetal in the formula is named by its element name. And then the second nonmetal is named using the first syllable of the name followed by IDE, IDE. So this is kind of similar to naming ionic compounds, right? However, there's one more rule for naming molecular compounds. When a subscript indicates 2 or more atoms of an element, a prefix is shown in front of its name. So in table 6.10, there's a list of prefixes that are used in naming molecular compounds. And these prefixes tell us how many of each atom we have. So if you have, I don't know, let's talk about a molecular compound, NO2. So we would name this nitrogen dioxide. So notice that there's only one nitrogen, so we just name it nitrogen. And then there are 2 oxygens. So we put a prefix, di, which means 2. So that's up above. And then similar to our ionic compounds, we just use the first syllable of the second nonmetal, and then we follow that with IDE. Now, notice that in front of nitrogen, I did not put mono. So this is not mononitrogen dioxide. And if your first nonmetal is by itself, we just don't include mono in front of it. It's just understood that it's by itself. However, if the second nonmetal is by itself, so let's say we have CO as our molecular compound, we would name this carbon monoxide. So again, the first nonmetal is by itself, but we don't include mono in front of it. And then the second nonmetal is by itself as well, and we do include mono. So we do not put mono in front of the first nonmetal. It's just understood that it's by itself. Okay, so then what if we have more than one of the first nonmetal? So maybe we have something like, let's see. So maybe we have N2O. Then we would indicate how many of the first nonmetal we have. So we would put dinitrogen monoxide. So we have di to indicate that there are two nitrogen nonmetal atoms, and then mono in front of oxide to indicate that there's one oxygen nonmetal. All right, and then if you do need to brush up on some of these prefixes, definitely make flashcards for this table 6.10. So one means mono, mono means one, di means two, tri means three, tetra is four, penta is five, etc. Now, normally we don't see a lot of hexa, hepta, octa, etc. because when we start having when we start seeing compounds with multiple atoms of one element, usually those compounds have a different naming scheme, so we're not going to see those as much, but definitely know these first five because those will come up a lot. Okay, so several compounds may be formed from the same two nonmetals, and we just saw this with NO2 and N2O, but also CO2 and CO contain the same elements but with different numbers of each element. So carbon dioxide has one carbon and two oxygens. Carbon monoxide has one carbon, one oxygen. Now, carbon dioxide is what we breathe out. Carbon monoxide is released by various sources and is poisonous to us because carbon monoxide is really similar to oxygen gas. So oxygen has two oxygen atoms bonded together. So it looks like this. Sort of. We'll talk about the correct structure for O2 or oxygen gas. But basically, carbon monoxide, if you breathe it in, can replace oxygen in your system and can slowly poison you. So that's why you might see carbon monoxide detectors in your apartment or your home or in various places. But that molecule is very different from CO2, which is what we breathe out. All right. Anyway, so the number of oxygen atoms present is again indicated by the prefix. Now, one thing also to keep in mind, if you have a name where there's two vowels next to each other, so OO or AO, the first vowel is dropped. So for instance, we have NO, which is nitrogen monoxide, but we don't call it monooxide because that kind of looks like monoxide, which is not correct. So we drop one of the O's and it becomes monoxide. Additionally, if you have four oxygens in a compound, we would call that tetroxide, not tetraoxide. So there's just a few little things like that. But I'm not going to be too nitpicky on that since you're just now learning how to name covalent compounds. So, once you get to general chemistry, your professor might be a little pickier about naming, but for now, as long as you have the general idea of the name, so you have the correct prefix and the correct nonmetal name, then that's good for now. Okay, so let's do some practice. Let's name the molecular compound NCl3. And if you want to try this on your own first, pause the video, and then when you come back, we'll try it together. Okay, so it looks like we have nitrogen and chlorine. All right. So again, we're going to start with the first non-metal, so that is nitrogen. And nitrogen is by itself, but again, remember, if the first non-metal is by itself, we do not include a prefix. So let's write that down below. All right. Okay, so now let's move on to the second nonmetal, which is chlorine. So there are 3 chlorine atoms there, so we need to use the prefix that indicates 3. So that is tri. And then we're going to use the first syllable of the nonmetal, which is chlor. And then we're going to end that with IDE. So this is nitrogen trichloride. Okay. So again, naming molecular compounds is similar to naming ionic compounds. The second atom is the nonmetal in both cases, and we use the first syllable of the nonmetal and follow it with IDE. However, if you have a molecular compound, so 2 nonmetal atoms bonded together, then you're going to add prefixes. And we'll go over a summary later on. All right, and here's the solution slides. So let's try another one. Let's say we have the molecular compound B2O3. How would we name this one? And feel free to try it on your own first. Okay, so for this one, we have boron and oxygen in this compound. And it looks like we have 2 boron atoms. So this time we are going to include a prefix in front of the first nonmetal because there's more than one. So we would call that diboron to start. And then there's 3 oxygen atoms. So again, we need a prefix to indicate that. So we'll put in tri, and then we'll use the first syllable of that nonmetal, which is ox, and we'll follow it with IDE, ide. So diboron trioxide. Now, again, the reason we need these prefixes is we have 2 nonmetals that are bonding. So, or 2 elements, I guess, that are in this compound. And they're not going to transfer electrons, they're going to share electrons. Now, in an ionic compound, we have ionic charges that we can use to figure out the names or the ratios, etc. But with molecular compounds, they don't have charges. So we can't really figure out a formula from the name unless we include prefixes. So that's why we're using prefixes, because we don't have charges here. All right, and here's the solution slides. So now, again, what if we want to go in the opposite direction? What if we're given a name of a compound and we have to figure out the molecular formula? So again, prefixes will be given for each nonmetal to indicate how many of each we have. So to write the formula from the name, we use the symbol for each element and a subscript if a prefix indicates that there are 2 or more atoms of that nonmetal. So let's look at an example. Let's write the molecular formula for diphosphorus pentoxide. And if you want to try this on your own first, feel free, and we'll go over it together in a bit. Okay, so it looks like we have two nonmetals, which is great because this is a molecular compound. So we've got phosphorus and oxygen. Okay, so that's P and O. Now we have to figure out how many of each we have. So in front of phosphorus, we have the prefix di, which indicates 2. And then in front of oxygen, we have pent, which means 5. Okay, so that means we have 2 phosphorus atoms and 5 oxygen atoms. So this would be P2O5. All right. And here are the solutions, or there's the solution slide. So how do you determine if a compound is ionic or covalent? Now that we've seen how to name both types of compounds, how do we figure out which one is which? So a couple of things to remember. A compound is usually ionic if the first element in the formula or the name is a metal or the polyatomic ion ammonium. So for instance, let's say someone shows you this molecular formula or this compound formula, K2O. So the first atom is potassium, and potassium is a metal. So that means that the compound is ionic. So then we would use our ionic compound naming rules to name that compound. So this would be potassium oxide. So we have the metal first, and then a space, and then we name the first syllable of the nonmetal plus IDE. All right, now a compound is usually covalent if the first element in the formula is a non-metal. So in N2O, nitrogen is a non-metal, so that means the compound is covalent. So then we would use our covalent compound naming rules where we use prefixes. So this again would be dinitrogen oxide. So for covalent compounds, we name this using a prefix unless the first nonmetal is by itself, so that's the exception, plus the first nonmetal name. Then we leave a space, and then we add a prefix to the first syllable of the second nonmetal, plus IDE. All right, but remember, I'm going to put a little asterisk next to that prefix in front of the first nonmetal because, again, if it's by itself, we don't include a prefix. It's just one of those naming rules that someone came up with somewhere. All right. So let's do a learning check. Let's identify each compound as ionic or covalent and give its correct name. So let's do the first one together. We have sulfur and 3 oxygen atoms. So do we have a metal in this compound? No, sulfur and oxygen are both non-metals. So no metal atoms means we have a covalent compound. Okay, so now let's name this using our covalent compound naming rules. All right, so that means we want to use prefixes. Okay, so sulfur is by itself, so it doesn't need a prefix. So we just have sulfur to start. And then we have 3 oxygen atoms, so we do want to use a prefix there always. So that will be tri-oxide. oxide. Okay, so now I encourage you to try the rest of these on your own, and when you unpause the video, we'll go over them together. Okay. So our next compound is BaCl2. So are there any metal atoms in that compound? Yes. So barium is a metal, and you can use your periodic table to figure that out. Remember, you're always allowed a periodic table on exams or quizzes, so always feel free to have that handy. Okay, so barium is a metal, so that means this is an ionic compound. So we want to name this according to our ionic compound naming rules. All right. So remember from our rules, we name the metal first, and then we name the first syllable of the nonmetal plus IDE. Okay. So we'll name this barium. And then we have chlorine. So we're going to use the first syllable, chlor, and follow that with IDE. All right. Now C, we have NH4 3PO3. Okay, so in this one, it looks like we have two polyatomic ions. We have NH4 and then PO3. So those are our polyatomic ions. And this is why it's important to know the polyatomic ions, because then you'll know or be able to recognize them when they pop up in a compound. Okay, so in this instance, we have two ions, so this is an ionic compound. Now, when you have polyatomic ions in a compound, you just name the polyatomic ions and you don't worry about changing them or doing anything to them. So this one's going to be super easy as long as you know the names of the polyatomic ions. So our first polyatomic ion, NH4, that is ammonium. And then the second polyatomic ion, it looks like phosphate, but phosphate has 4 oxygens. So remember, if you have one less oxygen, PO3, we change the ending to ITE. So this would be phosphite. So again, another reason it's important to know your polyatomic ions. It can affect your naming of compounds. All right, so now D, we have copper and CO3, which is a polyatomic ion. Now, do we have any metals? Yes, copper is a metal, right? So we have a metal and a polyatomic ion. So this is an ionic compound. Okay, so we're going to use our ionic compound naming rules. However, remember, copper can have multiple charges. So that means we have to indicate the charge of copper in parentheses and Roman numerals. So this will be copper, and then we have to figure out the charge. So if you pull out the polyatomic ion sheet that's available on Canvas, you'll see that CO3 carbonate has a 2- charge. Okay, and then we have 2 copper ions. So let's draw a little picture. We've got copper, copper, and then we have CO3, 2 minus. Okay, so to balance the charge on the carbonate polyatomic ion, we need both of these copper ions to add up to +2. Okay, so that must mean that each copper has a +1 charge, right? Because they add up to 2. All right, so that tells us that the charge on copper is 1. So we'll put a Roman numeral in parentheses there. And then remember with polyatomic ions, we just name the polyatomic ion. So that would be carbonate. All right. Now for our last compound, N2O4. Are there any metal atoms or polyatomic ions in that compound? No, nitrogen and oxygen are both nonmetals. So this is a covalent compound or molecular compound. Okay, so we're going to name this using our molecular compound naming rules. So we want to use prefixes. So there are 2 nitrogens, so we'll call this dinitrogen. And then there are 4 oxygens, so that would be tetraoxide, but we're going to drop the A, so it's tetroxide. So dinitrogen tetroxide. Okay, so hopefully this helps a little bit with figuring out whether you have a covalent compound or an ionic compound. And then we also saw a lot of variety in terms of how to name those different compounds. So some had polyatomic ions, some had metal ions with variable charge, and so we got to see a lot of different examples here. All right, and then here are the answers to those problems if you want to look those up later. So now we've covered all of the different naming rules. So you can consult this chart to kind of help you figure out how to name different compounds. So again, if you have an ionic compound, there's either a metal or the ammonium ion, or just any polyatomic ion really. And then if you have a molecular compound, you'll have 2 nonmetals present. And then we've already gone over how to name ionic compounds pretty extensively, so let's just focus on the molecular compounds. So again, remember you're going to name the first nonmetal, and you're not going to change that name. And then you're going to use a prefix to match the subscript before the element name, unless the element's by itself, and then we just don't include a subscript or a prefix. And then the second nonmetal is named similar to ionic compounds. So you use the first syllable and end it with IDE, but the one difference is that you're going to use a prefix to match the subscript. All right, so I'm going to end the video here. Next time, we're going to talk about how to draw structures for molecular compounds and also polyatomic ions. Because remember, polyatomic ions do have covalent bonds within them. They just have an overall charge. So we'll start drawing what are called Lewis structures. So I will see you in the next video.